So in this video, I will show you how to further play with some filters and the optimization step using the parallel coordinates plot. So here I've specified a filter for the response column. The filter is for the values that I find very interesting. Now, what you can also do is specify filters for your input variables. Now, all the input variables in this case for my data set have a low value of -1 and a high value of 1, which may not be the case for your data set, in which case you will see different values based on your low and high values for each column in your data set. Now, for my data set, I can specify here that I am interested in values only from, let's say, around 0 to -1. Maybe this is x1 corresponds to some expensive chemical that I use in the process, and I want to use a very minimal amount, so I don't want to use higher amounts. I will just use lower amounts, and I want to see if my model can predict certain combinations where only the lower amounts for that chemical is used. And you see that in fact this is a feasible filter because I still have certain combinations that go through these values for the response. Now, it is possible, however, for you to drill down even further. Now, even though I've specified this limit, I can click on zoom, in which case it will take the filters for your input variables. So let me specify another filter over here, maybe from 0.5 to 1, and I'll click on zoom. And then what it does is for x2, x4, x5, and x6, nothing changes. Everything goes from -1 to 1. But the ranges for the x1 and x3 variable have changed because I have specified very specific filters. And the discretization level that I've specified for the PCP takes into account this filtered or narrow range, and then only discretizes the levels for that specified range.